Okay, I think I forgot to mention something, that if the series, let's say I from 1 to infinity, equals to some number, which means that the limit of this k, the limit of this as k goes to infinity exists. So then we say that the series is convergent. And if the limit does not exist or be infinity, then we say that the series is divergent. Okay, some definitions just. Now, but most of the, in the previous series, I mean the geometric and the telescoping ones, we could find the value of this series, but most of the times this is not possible, or it's hard to find the value of a series. But for instance, in the case I talked about, which was about the solving some differential equations, which we want the series just for the approximation sake. Okay, and we couldn't, or we don't need to find the value of that series. Okay, but what we need was that, or is that, we need to know that whether a series is convergent or not. So how could we find that a series is a convergent one? We got some tests. Now I talk about the tests in this video and some 1 or 2 next videos. Okay, the first test is the comparison test, which says that, and works for the, is about the series with the positive terms. Okay, and says that if you got 2 series, let's say AI and BI, and the AIs are smaller or equal to BIs, then no, and also this is convergent, then then this is also convergent. Okay, and these are positive. For instance, say n factorial, n equals 1 to infinity. And you may see series containing factorials in them, these are real series, like the Taylor series. I talked about it before, in which the terms was like that. the nth derivative of f at 0, x to the power of n over n factorial, if you remember that. Okay, now in order to find that whether it is convergent or not, this is positive, okay, and it is smaller than 1 over 2 to the power of n. Why? Because what is n factorial? It is 1 times 2 times 3 dot 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 times n. Okay, so we got n numbers here. Oh, let me, and you know, this is 2 minus 1, sorry. Okay, and let me write it this way, and this is 1, this is 2, but let's write here, sorry, dot dot n. Okay, it is greater than 1 times 2 times again 2, again 2 till n itself, and replace it by 2. Okay, 3 is greater than 2, 4 is greater than 2, and n is also greater than 2. So we got n minus 1 number of the 2's, so that would be 2n minus 1, and if they go to the denominator, that would be, this would be smaller than this. Okay, and what is it? It is a starting from n equals 1. Okay, this is what? This is the geometric series, right? Which is convergent. So it should be convergent also. But you know, this test is for when the AIs be positive and BIs be positive. But what about the time when this is not positive, you know, necessarily positive, like say this series, minus 1 to the power of n over n factorial. You know, this is positive and negative for n. For the odd values of n, this is positive, but for the for the odd values of n, this is negative, and for the even values of n, it is positive. Okay, so what in that case we should do? We got a theorem which says that if the absolute, the series of absolute values of terms be convergent, then this is also convergent. Okay, so it's easy. We know that this equals to 1 over n factorial and is convergent. So this is also convergent. Okay,